Welcome back. So now what I want to do is list out a bunch of rules for differentiation of vector functions. So let's let u and v be vector functions of a real variable t, and so these are vector functions in the same space, and let c be a real number. Let f of t be a real valued function of t. That is, f of t is a scalar function. So I'm using the arrows here to differentiate the vector functions from the scalar functions. So when I say the word scalar function, it means that f of t is a real valued function of t. Again, vector functions, those are vector valued functions of t. Okay, the rule number one is that the derivative of u of t plus or minus v of t is the same as the derivative of u plus or minus the derivative of v. So rule number one tells us that the derivative of a sum of vector functions is equal to the sum of the derivatives of the summands. The rule number two is that the derivative of c times u of t is the same as c times the derivative of u. So it tells us that if we have a constant factor in the function, then the constant factor can be taken outside of the derivative, and we get c times the derivative of u of t. Property number three is the following. So u of t is a vector function, f of t is a scalar function, so we can multiply the vector u with the scalar f, and if we are taking the derivative of this function, this product here, this is multiplication, this is scalar multiplication, right? So then the derivative here would be exactly like the product rule that we have seen before. It's the derivative of f multiplied by u of t plus f of t times the derivative of u. Again, the derivative of the scalar function is as usual that we have seen in the previous calculus courses, and then the derivative of u, that's the derivative of a vector function here. The derivative of the dot product of two vector functions is equal to u prime of t dot product to v of t plus u of t dot product with the v prime of t. Again, this is exactly like the product rule. The only difference is we are using dot product here. The derivative of u of t cross product with v of t, that also follows the product rule, so it's u prime of t cross product with v of t plus u of t time cross product with the v prime of t. Lastly, the property number 6, that's the chain rule. So if I'm taking the derivative of u of f of t, then that's the same as the derivative of u evaluated at f of t dot product with f prime of t. So here, this is dot product. Sorry. So this is so u of f. So when I'm taking the derivative of u of f of t, that's the derivative of u evaluated at f of t multiplied by f prime of t. Here, this multiplication is scalar multiplication. That is, this guy here is a vector, and this is a scalar. Okay, so these are all the properties of differentiation of vector functions.